We're going to take a look at trig functions and some of their properties, and one of the properties being that they're periodic functions, and we'll see what that means in a minute. Now, what I have on the board is something that we talked about in a previous lecture, where we could kind of redefine our trig functions based off of a point in the plane. And these were the definitions that we came up with. We also discussed in that lecture that the radius here could really be any radius that we want it to be, but that a lot of times, to make things more simple, we would let the radius be 1. And when we do that, we end up with something called the unit circle. Now, the unit circle is a great way to help you memorize the trig values of a lot of functions, because it greatly simplifies these definitions. Because if our radius is 1, as we saw in a past lecture, for every point that's on that circle, the sine of whatever angle it is just the y value of that point. The cosine is the x value, and the tangent of that angle is still the y divided by the x. And of course, the reciprocals of these, the cosecant would be 1 over y, the secant would be 1 over x, and the cotangent would be x over y. So if you notice, by making our radius here 1, we end up with these really nice definitions for sine and cosine. So another way to think about this, or kind of visualizing what I just said, if we have a circle with radius 1, there we go, act like that looks like a circle. If we were to pick any angle here, I'm just going to, draw one over here. There's our angle theta. As long as this circle has a unit 1, whatever the x value of this point is will be the cosine of that angle, and whatever the y value of that point will be the sine of that angle. So if you get up on just search on Google or wherever, unit circle, you see pictures that have all your basic known angles laid out and every single point already on there for you. It's a really easy way to help you memorize the sines, cosines of our basic known angles. So it's a good memorization tool. Now, by thinking about this as the unit circle, we can now talk about things like domain and range of a function. Now, back to a few definitions from the past. What is the domain of a function? Well, the domain is the values you are allowed to plug in. So, easiest way to see that is taking a look at an example of something that has values that you can't plug into. So if we had the function, say, 1 over x minus 3, right, a rational function here, you could see that we would never be allowed to plug 3 into this because it would make our denominator equal to 0. But that's really the only number that would cause this function any problems. So the domain here would be all real numbers. Remember, that's our symbol for all real numbers, the script er, except for x being 3. So it's the stuff you're allowed to plug in. Now the range are the values that can come out. So what kind of answers can you get? So that one's generally a little bit more difficult question to answer when we're taking a look at domain and range. Range is normally a little bit more difficult, but it's like, what kind of answers can you get out of the problem? Let's take a look at a picture maybe to understand range a little bit. If we take a look at our old friend x squared, just f of x is equal to x squared. The range is always talking about kind of the y values in a picture like this. Now notice the range, the lowest y value that could ever come out would be 0, but the highest goes on to infinity. So the range for this, and I'm going to use interval notation, goes from 0 to infinity. Remember, the square bracket means included, parentheses means we don't include it. So range are the values that the function can take on. So let's take a look at our two main trig functions here, sine and cosine, and see if we can determine what the domain and range of each one of those actually are. So let's start with our sine function. And let's look at the domain and the range. Now, if we assume that this is our unit circle, so I'm going to go ahead and make that a 1 right here. We said the sine, what comes out of the sine is the y value. So the y here would be our range, and we're plugging in the angle theta. Now, if you think about this, as we go around our circle, we can go around the circle as many times as we want. So we can actually put in any angle that we want, either positive angles or negative angles. So the domain, the angles we're allowed to plug in, we can plug in any angle that we want. So our domain goes from negative infinity to positive infinity. What's the range though? Well, if we're thinking about it as on a unit circle, and the output is the y value, what's the biggest y that can come out on a unit circle? Well, that would be this point up here. So the biggest value that can come out is 1. So the biggest is going to be 1. What's the smallest value the y value can be? Well, that would be when we're down here on the unit circle. So that would be a y value of -1. So the biggest the sine function can ever be is 1. The smallest it can ever be would be -1. So we can plug in anything we want to the sine function, but the biggest it can ever be is 1. The smallest it could ever be is -1. What about the cosine? All right, if we're taking a look at the cosine, the domain's going to be kind of the same idea, right? Because we're just plugging in an angle, and since we're going around in a circle, we can go around as much as we want in either direction, so positive or negative. So my domain for cosine is going to be the same, negative infinity to positive infinity. But what about the range? Well, the range, what comes out of cosine are x values. So what's the biggest x value can be when we're on our unit circle? Well, now we're talking about left and right for in this case. The biggest it can be is if it was way over here, that would also be 1. And excuse me, the smallest it could be is if we were over here. The smallest x value is over here, and that would be at -1. All right, so if we notice, the domain and range for both sine and cosine are exactly the same. Now these are the only two we're going to talk about today as far as domain and range. The other ones get a little bit more tricky, and it's actually easier to kind of get the idea of what their domain and range is from a picture. So we're going to take a look at that in a couple of lectures from now. All right, now that we can kind of get the idea of maybe a unit circle as us going around in a circle, we can get the idea of what it means to be periodic. Now, periodic just means that something repeats itself after a certain amount of, we'll say time, after a certain distance or time, it just starts to repeat itself over and over and over again. So let me go ahead and get this out of here, give us a little bit more room. So let's get a definition here. A function is said to be periodic with period m, just making up a letter here, if f of x is equal to f of x plus m. So the idea here is if you start at some spot, if you go that distance m away from it, you're going to get the same value. Now, in generally speaking though, it has to stay periodic for it to be considered periodic. So, and we generally let the letter n be a natural number, natural or a whole number, but whole will work, but natural number generally. That just means, 1, 2, 3, 4. So this would be true, it works again if it's a whole number. If we say f of x is equal to f of x plus n times n. So what does that mean? By putting the n here, it just means that it repeats itself. So if we go over one distance of m, that's what this one says, or if we go over 2 distances of m, or 3 distances of m, 4 or 5, whatever, it just means that the function repeats itself. Well, like I said, if we think about terms of sines and cosines, you notice as we go around our unit circle, we're going to have y values that repeat itself. Remember, the sine function is related to the y values, so since the y values repeat themselves over and over and over again, sine is going to be a periodic function. So let's take a look at this. Sine is periodic, that's the word periodic, with period. Let's see if we can figure out what the period would be. So here's kind of an easy way to see it. As we go around this circle, when are the y values going to kind of repeat themselves? We think about as we move around, the y values are going up on this side to go around our circle. Let me go ahead and kind of draw part of our circle. So as we're increasing our angle from angle 0 to 90 degrees or 0 to pi over 2, the y values are going up. Now as we go this way around our unit circle, the y values go up to down. Now we had positive y values and positive y values, but these were going up and these were going down. Now if we keep going, now our y values are negative, but they're going down. On this side they're negative, but they're going up. However, if you notice, once we make it all the way around, we actually start repeating the exact same pattern here. Another way to think about it is our pattern went, the answers would be positive, positive, then negative, negative, then it repeats itself, positive, positive, negative, negative, so on and so forth. So when does this positive, positive, negative, negative repeat itself? Well, it repeats itself every time we make it all the way around, which means this thing has a period of 360 degrees or 2 pi, which means the sine of an angle would give you the same answer if you have the sine of that angle plus 2 pi. Now that's if we just go one time around. Now of course we'd get the same answer if we went around 3 times or 4 times or 50 times. It doesn't matter how many times we go around. If we get back to the exact same spot, we'd have the exact same answer. So this is also equal to the sine of theta plus, now we're going to do what we did here. We're going to multiply our 2 pi by n. So we're going to go n times 2 pi. Now, generally, you're never going to see it written like this, but it means the same thing. I'm just going to move the n in there where the kind of letters are. So we're going to write this as 2n pi. All this means is the n means a multiple of 2 pi. So anytime you go around. So that's all you're thinking of 2n pi is ever how many times you want to go around the circle. Now, if we think about cosine now, cosine is periodic with period. Well, let's talk about cosine now. Now remember, cosine is talking about the x value. So this was a little bit more difficult for some people to see. So as I'm going around the circle, we're talking about our x value. So when I'm over here, remember if we're on our unit circle, this is the point 1, 0. So we have an x value of 1, and then we're going this way. So the x values are getting smaller until I get to an x value of 0. Then the x values are negative over here till I get to an x value of negative 1. Then the x values go from negative 1 back to 0 when we get to this point, and then from 0 to 1. So it's kind of easier to see if we actually take a look at the sign of the cosine in each quadrant. Well, everything's positive here, then it is negative, then cosine's negative again, then it's positive. Notice we really don't have any repeating there, but when we go around again, of course, it's going to go positive, negative, negative, positive, so on and so forth. So you can see we're repeating again once we go all the way around. So this is also periodic with period 2 pi. Now you can get rid of the circle, and I'm going to have to redraw it because I did a bad job of placing it there. So just like I wrote above, here we can say the cosine of the angle is the same as the cosine of theta plus 2 pi. And generically speaking, we can say that's the cosine of theta plus ever how many times we want to go around. So 2n pi. All right, let me draw my picture over here, same one I just had up, just to give us a little something else to look at. So here we go. Again, act like that this is a circle. And we had all students take calculus. All right, what about tangent? Well, tangent is also periodic with period. Let's see what tangent's period is. Now, tangent's a lot harder to talk about the x and y value, because remember, the tangent's actually what? The y divided by the x, right? The opposite over the adjacent. So instead of looking at that, let's do what we did kind of with the sines and cosines. Let's just take a look at the sine of tangent in each quadrant, SIGN. So what does it do? It goes from positive to negative to positive to negative to positive. Now notice we're repeating here a lot quicker than we did before, right? Because we're going positive, negative, positive, negative. So we go positive, negative, and then we repeat positive, negative. So we only had to go halfway around for this to repeat itself. So its period isn't 2 pi, it's actually only pi, or halfway around, 180 degrees, which means the tangent of an angle is the same as the tangent of that angle plus pi, or generically speaking, the tangent of that angle plus any multiple of pi, anytime you go halfway around. And again, that's kind of how you want to interpret that in pi. It's anytime you go halfway around your circle. So all of our trig functions are periodic because the reciprocals are as well. Same kind of pattern there. And you can kind of hopefully see why that they're periodic with this. Now we're going to see this a lot more in a couple of sections coming up, where we can actually visually see from the graphs, when we actually do graph these functions, visually how they are periodic. All right, let's take a look at a few more properties of our trig functions here. Let's go back to some old topics. Let's talk about odd and even functions. Now, when we're talking about odd and even functions, we're talking about a symmetry of some sorts, depending on which way you want to look at it. A function is said to be even by definition if this is true, if f of x is equal to f of negative x. This is called y-axis symmetry. So a function that is even would be our old friend the parabola. So let's take a quick little look at this. So if we take a look at our parabola, by definition it says f of x has to be equal to f of negative x. Now remember, f of x is a y value. So what's that saying is you come over here to an x value and you plug that into the function, you get f of x. So you plug in an x, you get a y value. Now, to have y-axis symmetry, or to be even, if you go the same distance the other way and you go up, that would be the y value of f of negative x. Now, kind of from the picture you can see here, that if we go the same distance on each side, we get the same y value. Or symmetrically, if we were to fold this graph on the y-axis, one point would lay on top of the other, hence it has y-axis symmetry. An odd function, this one's a little bit harder to explain. This says f of negative x is negative f of x. This actually has origin symmetry. So a function you may recognize from the past that is odd, or has origin symmetry, would be x cubed. Remember, x cubed kind of looks kind of like this kind of S shape that comes up here. So this one requires a little bit more imagination to kind of see visually how one folds on top of the other. You actually have to fold this picture twice. It doesn't matter which one you fold first. If we fold it on the y-axis, let's say this way, like we're turning the page of a book this way, you can see that this side, hopefully, would fold up something like that. Then that's folding on the y-axis. Then if we take and fold it on the x-axis, hopefully you can see that the dotted blue here would lay on top of that piece. That's what it means to have origin symmetry, that if you fold on both axes, the graph lays on top of itself. Now, mathematically speaking, let me get that out of here. Our definition says that f of negative x has to be the opposite of f of x. So first off, let's just take a look at f of x. So if I come over here to an x value, we can call that f of x. I go the same distance the other way, that's negative x. Down here, this would be f of negative x. So for this to happen, you can kind of see that this point would have to go over to here, and then that point would have to go down to here. So this distance here has to be the same as this distance here, just the opposite of it. So we say that this y value is the opposite of this y value. Or f of negative x is the opposite of f of x, right? If this is 7, this would be the opposite of that, negative 7. So that's what it means to be odd and even. Hopefully that was a quick little refresher. Now our trig functions also fall into the category of odd or even. Now, of course, by the way, if a function doesn't have either one of those properties, we just say that it's neither odd or even. But our trig functions actually are odd or even, at least the basic ones. So if we take a look at just the sine of theta, this is an odd function. Now, being an odd function, that means that this here is true. So that means that the sine of negative theta is equal to the negative sine of theta. Now, the biggest mistake that students make here is they say, oh, I'm allowed to pull that negative out front. That is not what we're doing here. I'm using the fact that it is an odd function. So I'm using this definition of an odd function to be able to rewrite the sine of negative theta as the negative sine of theta. We're not doing any algebra to pull that out front, so be careful with that. The cosine of theta, cosine is an even function. Well, by the definition of the even function, it says that the cosine of a negative angle is the same thing as the cosine of the positive angle. Right? Cosine's even. Again, just I'm using this definition right here. Now for our last one, I guess I'll stick it right here, our tangent function. Now you kind of think about this in terms of like positives and negatives. If you think about odd as negative and cosine being positive, I can see that I know tangent is sine divided by cosine. So a negative divided by a positive is a negative, or an odd divided by an even is an odd function. So tangent is odd. So using its tangent is odd, so the tangent of negative theta is going to give you the opposite of the tangent of theta. Again, not pulling out the negative, I'm using the fact that I know that this is an odd function. All right, so redefining our trig functions using a unit circle is going to be a nice way to help you memorize them. Again, I suggest jumping up on the internet and taking a look at some pictures of some unit circles. A very, very nice tool to help you memorize them. By doing that, it makes it easier to see the domain and range of our trig functions. And you do need to know what the periods of our trig functions are. The period of sine and cosine is 2 pi, where the period of tangent is pi. And knowing whether or not they're odd and even is also very useful for your future.